we're going to integrate using trig substitution the integral of x over the square root of x squared plus 2x minus 8 dx. Now this is a quadratic, so we are going to write it so it will fit into the forms that we need for trig substitution. So we're going to rewrite x squared plus 2x minus 8 so it fits into either box squared minus 1 eventually, or box squared plus 1, or 1 minus box squared. Either of those forms eventually, those are what we use for trig substitution. So first step, I'm going to complete the square. We have x squared plus 2x minus 8. So we're going to complete the square with that. So I take half of 2, which is 1, and I square 1, 1 times 1, which is 1, and I add 1 to complete the square. But I'm doing a rewrite, so in order to keep this and not change the original, I have to subtract 1. So now this can be rewritten as x plus 1 squared, and then we have negative 8, and negative 1 is negative 9. Now we can see that this is going to fit into the something squared minus 1 when we factor out the 9. So my next step is I'm going to take the x squared plus 2x minus 8, and that's written as x plus 1 squared minus 9, and I'm now going to factor out the 9 so it can be in the form I want it. So that becomes 9x plus 1 squared divided by 9 minus 1. So this is the setup right away where this can be written as secant squared theta minus 1, which is what we're going to do in the substitution. So now I'm going to say x plus 1 squared over 9 is secant squared theta. Then I always take the square root. I get x plus 1 over 3 is secant theta. And now, once I have that, that is the step. That second step is the step where I have the triangle. And we know that the secant of theta is hypotenuse over adjacent. So the hypotenuse is x plus 1, and the adjacent is 3. Now this missing side would be whatever that is, question mark squared plus 3 squared should be x plus 1 squared. And sure enough, that missing side plus 9 is x squared plus 2x plus 1. And by subtracting 9, we get that that question mark squared is x squared plus 2x minus 8. Okay, so now that means that that missing side is the square root of x squared plus 2x minus 8. And that's good to know, because if we go back to the problem, what we get for that missing side should be what we have in the integrand. Now, going back here, I'm going to now solve for x, because we want dx from that. So I get that x plus 1 is 3 secant theta. So now I just subtract 1, and I get x is negative 1 plus 3 secant theta. Now that's important, because now I'm going to have what dx is. Dx is derivative of negative 1 is 0, and the derivative of 3 secant theta is 3 secant theta tangent theta d theta. So it's going to be important. I'm going to use these in that substitution. Okay, so now I'm going to write the problem again, and we're going to now do, I'm actually going to call this is like my key of sorts. because what we can see here is that I've got x can be replaced, dx, and sure enough, what we had here, the x plus 1 squared over 9 minus 1 becomes secant squared minus 1. So let's put the integral again. So the integral is, so we are dealing with x over square root x squared plus 2x minus 8 dx. So we're now getting ready to do the trig substitution. So the x here will be replaced with negative 1 plus 3 secant theta. The dx will be 3 secant theta tangent theta. This here was 9 times x plus 1 squared over 9 minus 1, which now when we replace it, this is 9 secant squared theta minus 1. So I'm now ready to put the equivalent integral. So this can now be written as negative 1 plus 3 secant theta. We have the dx is 3 secant theta tangent theta d theta. And then down here, it's square root of 9 secant squared theta minus 1. But this under here is really 9 tangent squared theta. So I'll be able to take the square root. Okay. So this gives us, working this through, I have the integral of negative 1 plus 3 secant theta. Then we have 3 secant theta tangent theta d theta. And under here we have square root of 9, 3. Square root of tangent squared is tangent theta. We're now ready to cancel and get a simpler integral. So at this point, I certainly can cancel the tangent. I can cancel the 3. So I am going to be left with a new integral. So I'm going to go to the next page to put that integral. So on the next page, I'm going to have this with the secant theta and the d theta. So let's move to the next page. Okay. So that integral was negative 1 plus 3 secant theta. We had another secant theta d theta. So now I'm ready to work that integral. But first what I'm going to have to do is distribute the secant theta through. So I'll have to distribute it through both of those. So that becomes the integral of negative secant theta plus 3 secant squared theta d theta. Okay, so now I do these antiderivatives. I have to memorize that the antiderivative of secant is the log of secant plus tangent. So this becomes negative the log of secant theta plus tangent theta. And 3 secant squared, the antiderivative of secant squared is tangent. So it's 3 tangent theta plus a constant. We now have a very nice answer, but it's only in theta, and we have to go back to x. So in order to do this, to go back to x, we have to go back to how we originally defined the triangle. And we're going back to this step. X plus 1 over 3 was secant theta, and it's that triangle that's going to allow us to replace secant and tangent and get them in terms of x. So I'm going to go to the next page and put in that triangle. So my triangle is that x plus 1 over 3 was secant theta. So that meant I need that triangle. So we know secant was hypotenuse. This was x plus 1. This was 3. And we figured out what the remaining side was. That side was square root of x squared plus 2x minus 8, which was in the original problem. What happened here? For some reason the pen didn't work. Let me make sure it's working. Yeah, okay. All right. Have to be careful. What happens when you go from one piece to another with this program? You have to go back and make sure you have the pen. Now, in this case, do you see, you guys, how can I simplify? Because I do want you to think about if you had to use Wolfram Alpha, how you would do that. Guess what I can do with that logarithm? I keep the negative in front. You're not going to do that. But guess what will happen with that? Well, it's can you see you can put everything over 3? But then it will be log of the top minus log of the bottom. But what's log of the bottom is log 3, which is a constant. So it'll get absorbed in the C right here. Okay, so I'm going to write the resulting 3. Okay, so let me just do another bit.